Sure.
Welcome everyone to this Malta Academy, building internal developer platform with Viktor Farcic. We will give a couple of minutes until everyone can join correctly the link and can hear us. There is a chat. Feel free to contact us to say whatever you want. We are here to answer all your questions, and hopefully you will learn something new today. I'm going to explain a little bit, meanwhile we wait everyone is here, about Malt and about Malt Academies. Feel free to present yourself in the chat. Malt Academies was born during the COVID lockdown, the first one. We wanted to bring some good impact to this difficult situation. We were wondering what we can offer, what we can help to give to the IT community. And we realized that what it was in our hands is to give free access to IT knowledge. So starting from the IT team that we have in Malt, we started to do these webinars, these Malt Academies, sharing our knowledge and trying to find like a good experience and good networking between all the IT community. We saw true value here, and it forced us to keep doing these Malta Academies, keep doing these events. I will share the link of the webpage of Malta Academies. There is full of different IT topics, from a simple knowledge to a high-level or master knowledge. There are in English, in French, in Spanish, in Germany. There are different languages, and all is for free. You will find it there. Moreover, Malt, it's the biggest European platform for freelance. If some of you didn't know us, we are the biggest community, more than 320,000 freelancers around Europe, most of them based in France, Germany, Belgium, Netherlands, and Spain. If you're a freelancer and don't know us, if you are interested to know more about freelancing, or if you are looking for a project, I will share my mail, and you can contact directly to me, and we can speak of how to boost your careers as a freelance. Actually, in terms of DevOps, we are having a huge demand of projects. It's international projects and our local projects. So if you want to know more, if you want to start projects and you have time right now, you can register on our platform. This is the QR to go to log in directly to Malt. If you contact me after this event, let you know that you have a discount if you start a project during this month. What it means, to log in on Malt is completely free. We only get a fee, we only get money when you win a project. So when you win a project, we will retain the 10% of this project. But if you contact me during this week and integrate your profile, you will have like a 50% of discount in this fee. So it means that instead of retaining 10%, we will only get 5%. Even if you are not sure if you want to get a project and so on, but even though you want to talk, here is my mail. I will share all of this in the chat, and you can contact directly to me and we can talk about that. But today, the important topic is Viktor. He's the expert on the area, and he's the one who will talk during all this time. I will remind here on the chat, so if anyone wants to talk about anything in concrete related to Malt, you can chat to me. If not, this is Viktor. Welcome to this webinar, to this Malt Academy.
Thank you. Oh, it's nice to be here. So let's talk about DevOps, right? Before I start, actually, I like to be interrupted. So if you have any questions or anything like that, just let me know. I'll do my best to watch the chat channel. So kind of stop me, right? Don't wait for me to talk for an hour and then ask questions and you say, I forgot what you talked about, right? So stop me at any given moment, ask questions. If you make this bidirectional, even better. Now, that being said, my name is Viktor. I am a developer advocate in Upbound. We're a company, a new startup, relatively new, behind Crossplane. I will show you Crossplane actually later because I think it's awesome. But for now, what I want to do is I'm going to switch to slides. There we go. And there we go. By the way, this is the first time I use slides in like years. I'm not very fond of slides. I like just speaking. But hey, trying something new. And by the way, speaking about DevOps, this is usually my reaction when people tell me about what they're doing. This is usually my face when I visit a company and get explanation of how they work, right? Anyways, so that's me, Viktor. I work for Upbound. I already mentioned. I'm a member of some foundations like CD Found, Continuous Delivery Foundation, Google Developer Experts, Docker Captains. I'm not sure whether Docker exists as a company, but if it does, then I'm a member of their group as well. Some books, courses that are not important, YouTube channel, doesn't matter. What does matter is that I will be talking about DevOps. Now, when we talk about DevOps, usually the first reaction that people have with DevOps is, hey, this is about containers, this is about Kubernetes, it's about cloud, GitOps, CI/CD, logging, monitoring, infrastructure as code, troubleshooting, security, service mesh, and so on and so forth, as if that somehow is DevOps. And very often what I see in companies is that a person or a team behind those tools rename themselves from, I don't know, in the past, maybe it was operations team, maybe it's production support, maybe it was platform team, maybe it was something else, doesn't matter, right? People just rename their title into DevOps, and usually that's done by people in charge of some of the tools I have here on the screen. It could be others as well. What does matter in this context is that those are just tools. They are not necessarily even DevOps tools, or what they're tools that we had before DevOps, we will have after DevOps. They're changing, but the logic of them is very, very similar. What does matter, however, is that we cannot expect developers, and when I say developers, actually, let me clarify that. Let me explain what I mean by developer in this context today. When I say developer, what I mean really is a person working on the end user application, right? So application developer, think of it that way, right? Because in reality, everybody is in a company working around software, everybody's developer, right? And I know that for a fact simply because everybody is writing code. And when I say code, what I really mean is you're writing something that can be interpreted by machines, whether that's Python or Go or Java, JavaScript, YAML, I don't care. If it can be understood what you did by machines, you're writing code. If you're writing code, you're a developer, right? So in that context, developer is basically a term today that explains everybody, right? Kind of not only front-end application developers, but operators. They write code, right? You're not clicking buttons anymore. People in CI/CD testing, let's say, right? You're not clicking buttons anymore, you're writing code. So everybody writes code, everybody's developer. But today, when I say developer, I will actually mean application developers, or developers or people working on end user applications, right? So in that context, application developers, the trouble is that they cannot use the tools that I mentioned before, right? And the reason is very simple, because there is no single person that knows in depth all those things, right? Hardly anybody, almost never, right? Because each of those things most of those things alone are extremely complex. Kind of understanding Kubernetes in depth, man, that takes years. And I'm talking about Kubernetes without Kubernetes ecosystem. Understanding AWS in depth, understanding GCP, Azure in depth takes time. Some things are easier, like GitHub, some are harder, but it takes time. So we cannot expect everybody to know all those things. And yet, we have to expect everybody to use all those tools. And the reason why we have to assume that everybody is going to use all those things is because the goal of every, let's say, advanced organization that is doing really, really well with software is doing the same thing. And that thing is enabling developers or application developers to be self-sufficient, right? We do not live in 1999 anymore, where you would have different groups of people, and then somebody would say, hey, I need a cluster. And then somebody else would respond, yeah, well, open a Jira ticket or send me an email. And then you wait for 3 weeks and then you get the cluster. Or, hey, I need this application defined. I need this application deployed, and so on and so forth, right? We do not operate anymore, at least the advanced segment of our industry, in terms of I'm requesting something and then somebody else is doing that something for me, because that's inefficient, right? That means that we need to wait for a long time. We do not know what's going on, and so on and so forth. That's horrible. That's 1999, right? What we are doing today, almost every company I'm in contact with is one way or another trying to shift left. Now, I often get questioned when I mention shift left, what it is. So in case you're not aware of the term, what shift left means, no, actually, I can explain it this way. Imagine a timeline of a life cycle of an application. We come up with some idea, then we maybe write some diagrams, clarify what that idea is. We write code, we write tests, and then we build that something, and then we deploy that something to one environment, then another, eventually to production, and then we observe and make sure that it's working correctly in production. Now, the exact steps differ from one case to another, but what really matters is that traditionally we would split people into 2 groups. Those on the left side of that timeline, which would be those people writing code of end user applications, maybe running some, maybe defining tests, not maybe, defining tests, hopefully. And then people on the right side of that timeline, which would be traditionally operators or sysadmins, right? You know, people who are not really directly involved with the application or not involved at all, but they're making sure that the system runs smoothly and everything is happening, right? And we're trying to avoid that by shifting left, meaning that the tasks that were done on the right side later, we want to do them from the very beginning, like security, right? You don't want to work on something for months and then realize, and then somebody comes with an Excel sheet and says, oh, you have those 57,000 security exploits, you cannot go to production. No, nobody wants that, right? You want to be secure from the start. You want to be tested from the start. You want to be everything from the very beginning, right? Or very early in the process. And that's what the expression shift left means, that all the tasks that were done traditionally on the right side of the timeline are shifting left. And the only way to shift left is to enable developers to do everything. And the only way to enable developers to do everything without waiting for you to do something for them is to create services. But I'm going to get to that point in a second. What does not work in shifting left is, and that is also happening very often, or at least was happening, is saying, now you do it. Just like we got full stack developers, which I think it was always a bad idea. And now we have what some companies call DevOps, kind of like you do everything. That team of 5-6 people is doing everything. They write code, they write tests, they define their applications, they set up their classes, and so on and so forth. That doesn't work either, simply because that's overwhelming and impossible. There is a different way, which TLDR is through services, but I'm going to get there, right? Now, I thought I heard some questions. Hello, everyone. Okay, no questions. Brilliant. Okay, so what the spirit of DevOps is really about removing the barriers between different groups of people, different teams, right? Removing the silos. And the best way to remove silos is to, well, not have silos, right? To communicate with each other, to work with each other, and so on and so forth. Now, but from practical perspective, we cannot all work, I don't know, 200 people in a company literally with each other sitting in the same room and stuff like that. And the way how we are accomplishing that productivity is by enabling developers to do everything. And we do that by creating services. So for example, if you think of, let's say, AWS, you do not send an email saying, dear AWS folks, can you please create a VM for me? No, they create the services that you consume, right? Whenever you need something, but if you need a VM, You click a button or you execute a command or you do whatever, you get a VM. If you need a cluster, you get a cluster. If you need an internet gateway, you get internet gateway, and so on and so forth. So your collaboration with AWS, let's say, and I'm using them as example, it could be Azure, it could be GitHub, it's whatever, by you consuming services created by those teams. Now, what we need to do is the same within a company internally. So all those different teams with different types of expertise should enable their expertise, should make everybody else in a company more productive by creating services that they can consume instead of waiting for requests to do something. Hey, I need this. Nobody cares about that, right? Shouldn't care. Instead, the attitude is, hey, you do not need to ask me anything. Here's a service, you consume it, and you get whatever you need, right? Everything. Now, that type of services, which was in the past done by platform teams, most of the time not really well, is what today we call internal developer platforms, right? And almost every bigger company I know of is one way or another right now working on their internal developer platform, or I will call it IDP short. And those are the platforms that enable developers or application developers, let's say, to do whatever they need to do. It's internal because it's internal usage. Like AWS would be external platform. This is internal. This is what you build in your company so that you can be as productive as it can be as developer, because they are your customers, right? If you're on the right side of equation, operator, security, something, this or that, your developers in your company, application developers, they're your customers. You need to satisfy their needs. And that's extremely important, because if you don't understand who is your customer, that's how we end up with big banks not knowing what they're doing. And finally, it's a platform, right, for obvious reason. Now, what internal developer platforms are really, and remember what I said at the very beginning, that how I said that no single person or no single team can know all those things. That's true, right? Kind of, there is no team that can understand in depth Kubernetes and cloud, AWS, Azure, Google, security, this or that. So we're building, most of the companies today, are building a layer on top of all those tools. We need those tools, but those tools are reserved for special type of expertise, the special groups of people. Then we're building all layers on top of those tools that will make consumption of services extremely easy, that will convert those tools from being detailed, low-level type of tools to being something that is accessible to everybody. So through that, we are shifting left. That's what operations and SREs and DevOps and security and so on and so forth, all those different specialized groups of people are working on today with a single goal: enable developer self-service, right? And the reason why we are doing that is, if you look at the right side of the equation, people on the right side, most of the, very often, not always, probably not in your case, but in case of somebody else, most of the time is wasted on tasks that do not really bring value. Like, if every day you create a new cluster, that's not bringing value, because I can replace you with a script. If you are doing some repetitive things over and over and over again, that's not really generating value. What is generating value is to codify that, create it as a service, right? Let's check the questions. Okay, I have a few questions, so I will pause for a second, and then we go back to my presentation. I like answering questions from Valid. So what is the relation between DevOps and cloud native? DevOps is a cultural change where we are removing barriers between different silos, right? Cloud native is a way how, it's a technical term. It's how we define, create, and operate applications or infrastructure, right? If something is, you can say that something really truly designed, not put into, but designed for Kubernetes or for AWS and so on and so forth, that would be cloud native. There are now certain rules, like it needs to be scalable, it needs to be distributed, and so on and so forth. But the major high-level difference is that DevOps is a cultural thing, right? It's how we remove silos or why we want to remove silos. But being cloud native is a technical term, right? And then more from valid. IDP equals build, test, integrate, CI/CD, and pipelines. No, IDP means internal developer platform. It's a platform. It's platform you build in your company. Would you say that OpenShift, Tanzu, Antos have achieved a certain level of IDP? If not, what they are missing? They are IDPs, but I will talk about them in a second and say why they are not necessarily the choice you should be making in a second. So why keep coming with questions? This is exciting. I like it. Okay, so why? Oh, I should be sharing my slides. Let me do that. Cool. There we go. So why self-service? I already mentioned because we want to free operations and all other types of groups of expertise or people to do what matters. And what matters is to be productive, and you're not productive and you're doing manually something over and over again. That's just silly. We're increasing productivity, we're reducing lean time, we're increasing deployment frequency, we're decreasing mean time to repair or MTTR, decreasing change failure rates, CFR, and so on and so forth. Now, there's a bunch of things. And later on, we can talk, I can show you there are numerous studies that prove that companies that are that well implemented self-service internally within themselves are more productive, right? That's not the only reason, but one of the reasons. And that's a common theme between successful companies when software is concerned, like Netflix and Google and Spotify and so on and so forth. They're all doing the same thing. And among other things, they're all having self-service so that everybody can do everything extremely fast and extremely easily. And then they're more productive. Now, let's talk about life cycle of application services, infrastructure. They're all the same. On a very, very high level, there are 4 things that you always want to do. First, you want to change the desired state. Desired state, and this is very important, right? A huge change in how we see systems compared to the past. Desired state is us humans defining what we want. Not how we want it, not when we want it, not how something should happen, and so on and so forth. We are just defining the desired state always. If I say, I want a cluster, a big cluster, that is my desired state. Not how that cluster should be created and so on and so forth. I'm just saying what I want. And then it's a job of something else to make sure that something happens. Anyways, we define the desired state, and we always today, all the desired state, all that is defined as code, and that something is stored in Git, right? So you can think of Git being the source, not the source of truth. Some people say Git is the source of truth. It is not. Git is not the source of truth. It's the source of what we want, which is not necessarily what it is. Then we perform some actions. Those actions could be build binaries, run tests, build images, store images or binaries in a registry, and so on and so forth. So there are always some actions. Now, what is important to understand is that in the past, actions were almost everything. Now, by actions, we are but for a while now, to distinguish actions that are performed once and only once, only one time, every time we make changes to the desired state, which is what we store in Git. And the third important step in the life cycle of everything is that we have mechanism to make sure that desired state, what we stored in Git, becomes reality. Whether that means creating a server, whether that means setting up networking, whether that means deploying an application or deploying a new release is irrelevant in this context. What does matter is that once we change the desired state, we perform some actions, we make sure that the actual state becomes the desired state. That's what it is instead of what I want. And finally, the last step in the life cycle of something on a very, very high level is to observe and continue making sure that that actual state continues being what we want. Okay, more questions. Brilliant. I like this. You're talkative, at least one of you. Valid. Can you elaborate on why it is not the source of truth? Some say it is not committed, it does not exist as one of the GitOps practices. Okay, so let me explain a bit better why it is not the source of truth. The source of truth is what something is, meaning that the source of truth is that I have a cluster. The truth is, that I have a cluster, let's say, that has 5 servers, that I have release 7 of application A running in that cluster with 5 replicas, and release 9 of application B running with 3 replicas, just as examples, right? That's what it is. That's the real truth. Git is what we want, and we are trying our best with GitOps, as you mentioned, to make sure that what we want, what is in Git, is what it really is. But there are cases where those two things are not the same. And if what is in Git is not the same as what it really is in your clusters, in your servers, in your infrastructure, then there is that discrepancy. But the real truth is the actual state. In Git is what we want to have, not necessarily what we have. And then Jorge says, I hope that I'm not butchering your name, Jorge. What would you deem to be a nicely devised abstraction IDP-wise? I'm going to show you that in 10 minutes, so I'm getting there. And while it says, if I understand you correctly, the state is the source of truth. The actual state, I call it the actual state, right? You have desired state and the actual state. The actual state is your clusters, your AWS resources, and so on and so forth. Okay, let's continue with the presentation. It's exciting. You're talkative. I like it. Now, if I would be designing an IDP today, and I'm repeating, it's very important to say today, because in the past, yesterday we were doing it differently, just as we were doing it differently the day before yesterday. And I'm fully aware that not everybody can do what I'm about to say. But if I would start from scratch today, then this is how it would look like, more or less. Let me just find, this is what I want, yes. So we have the actual state, the real state, which is usually 3 types of things. There could be more, but on a high level. Providers, this is your AWS account, or Azure, or Google, or on-prem, or Datadog, maybe Elastic, Splunk, and so on and so forth. Those are all different providers that you use, right? Including on-prem. And on top of those, or in this diagram below, we have some infrastructure where we have servers or clusters or databases and so on and so forth, right? That are built on top of those providers. And finally, we have applications, which can be your applications or third-party applications, meaning the applications you wrote, the code you wrote, or third-party, like you might be running MongoDB yourself, right? Or you might be using MongoDB from one of the providers, as an example. So, but this is the actual state. This is what is really happening. And then on the left side here, we have the desired state. That's what you are doing as a developer of any kind. Doesn't matter whether you're application developer, front-end, back-end operator, doesn't matter what you are. You are pushing to Git the desired state. That's the code, that's the manifest, that's the config, and so on and so forth. All that, actually, all that could be called code, because all those things can be interpreted by machines. Now, what we're trying to do is build, or most of the companies, bigger ones at least, build an IDP on top of that. And I will later come to the question about OpenShift and so on and so forth. And what that IDP does is basically, it is providing the information about the actual state so that you can see what's going on. That information, this arrow here, it's read-only, right? You do not go and do anything here directly. We do not do those things, right? you do not go to AWS and click a button to create a server, right? And there are many reasons why we don't do that. My favorite is because this is disrespectful to your colleagues, because they do not know what they're doing. It's undocumented because nobody can see what was done, why it was done. That's why we store the state in Git and never, ever, ever touch directly, unless in a case of disaster, the actual state. So when we talk about the internal developer platform, we are talking about it being able to show you the state in read-only mode, never to change it. And we are enabling, one way or another, people to change what is stored in Git, what is the desired state. And that can be through web UI, it could be through CLI, commands, from a terminal. It could be IDE, like Visual Studio Code. It can be anything, right? The user interface can have many different forms. Doesn't matter. And then we have an API. Now, API is the important part. That's a missing link. The only way for this to work, for us to be able to enable things happening, is by having all the tooling, everything on the other end, having an API through which we can communicate with it, right? And now comes also another important thing. You would never build that tool if you need to deal with 5, 10, 100 different APIs and so on and so forth. And this is now where Kubernetes is coming in. Kubernetes is the first time I know in my career that we have a attempt with reasonable expectation of success to have one API through which we can manage everything. And remember that, and please know that I'm here trying to distinguish Kubernetes API from Kubernetes scheduler, which is what schedules your containers and so on and so forth. So, and then we have some tools like pipelines, GitOps, infrastructure, RBAC, and so on and so forth. Those are your Terraforms and Pulumis and Ansibles and JUnits and Sonar Cubes and Jenkinses and so on and so forth. All the tooling over there, right? But unless you're specialized in one of those tools, you cannot interact. You cannot expect everybody to interact with all of them directly, simply because it's a fragmented experience. It is very difficult to learn everything, impossible, and so on and so forth. And that's where Kubernetes custom resource definitions come in. Now, a little bit of a background story. How much time do I have? A little bit of background story. Kubernetes was never designed to be used by anybody. And this is going to be a shocking thing that I'm saying, right? No, but you are not supposed to use Kubernetes directly alone, right? Because it doesn't give you what you need to have, right? By design, from day one, Kubernetes was designed to be extensible. And you can extend Kubernetes to do almost anything, either through third-party applications that are actually not just applications. It cannot be just any other application. It must be some third-party solution that creates new custom resource definitions and controllers in Kubernetes that extend its capability to do things. And those custom resource definitions can be anything. And that's what I'm going to show you in a demo in a couple of seconds. The point here, important thing, is that we can define custom resource definitions to actually explain what is any of those things, right? You have custom resource definitions that are matching every single resource in AWS, in Azure, in Elastic, Splunk, Datadog, how we define servers, clusters, databases, how we define applications, and so on and so forth. So stop thinking about Kubernetes as something that enables you to run containers. They're just one out of many, 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 many use cases, right? And I will show you that in a demo in very, very soon, right? So that's how most of the platforms that are being built now on a high level are thinking of doing, right? Everybody's going in the same direction. When starting from scratch. Now, most companies do not start from scratch. You cannot ignore the past. But when we are designing platforms today, That's the high level overview that almost everybody is following when starting from scratch. Now, tools which you are going to use are many, right? You need to manage applications and infrastructure. And the way how we manage infrastructure and applications today, that's Kubernetes ERDs. That's a standard, that's a given. We're still early in the process, but that's the only reasonable way to do it today. We have pipelines, apart from infrastructure and applications, pipelines. Any should do, because pipelines are the easiest thing, simply because if you did your automation and stuff like that, pipelines are just saying run this and then run that and then run that. That's the easiest thing, even though most companies are complicating it. So any should do. If you have to choose which one, because of the architecture we're talking about today, if you have to choose something from scratch, choose Argo Workflow. So Tecton, they're the only two solutions that I know of for pipelines that were designed to do what needs to be done, taking into account the extensibility of Kubernetes. We have synchronization. We need to figure out, if I go back, how this comes here, how desired state goes into Kubernetes, and then Kubernetes takes care of doing the operations to make that happen, right? So how this comes here, and the answer today is through GitOps tools. Argo CD or Flux, both of them are amazing. They're great. You cannot go wrong. Or Rancher Fleet if you want to experiment with something that is still very, 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 very green. We need to somehow orchestrate infrastructure, right? To have some kind of a system that will make sure that all the infrastructure is happening and it's mutating and it's going on and everything is continuously working. And for that, we have Crossplane. Now, I'm deeply involved with Crossplane, so call me subjective. But Crossplane is the one that went furthest of all the tools we have in the market. We have other attempts like ACK from AWS, Cloud Connect from Google, and so on and so forth. That group of infrastructure orchestration tools or control planes are great, but they are limited to a single vendor, and everybody's going multi-cloud now. We have infrastructure as code tools like that we from the past, like Terraform, Pulumi, Ansible. They're great, but they still did not solve the problem of how do I run and how do I define what I need as custom resource definitions. That's still unsolved problem that is going in the direction of Kubernetes operators, but not really well so far. Then we need to figure out, after infrastructure, how we're going to manage our applications. The best solutions I know for today, apart from Crossplane, which I'm biased, is Open Application Model and Kubevela. Both are enabling us to define what is an application. And now comes the important part. There is no such thing as application in Kubernetes alone, right? It's impossible to define in Kubernetes alone without extending it what is an application. You can define and say there is a deployment, there is a stateful set, there is ingress, there is a service, there is virtual service, and so on and so forth. But those are building blocks. There is no conceptual way to define application in Kubernetes alone. That's why we need something like Open Application Model, right? And security, RBAC, not security, access control, how we make sure that only certain people can access only certain things. And that's extremely easy. And that's extremely easy simply because if all the desired state is stored in Git, I do not care about access control in my clusters, in my AWS account, and so on and so forth. All I really care is who can access Git and what they can do over there. So the process, I'm going to skip this, all these slides, and go actually answer the question and then go into the demo if I have time. Question about OpenShift and so on and so forth. So what do we do in IDP summary? Everything is tailor-made to match the needs of the people working in a company. And then the question is, should you buy it or build it yourself? You can buy something like OpenShift. Or even better example than OpenShift, if any of you is old enough in this industry, Heroku, right? You can buy a platform that will do the things for you. The problem with buying a platform is that it will do whatever needs to be done, but it is always opinionated, right? It does things a certain way. And then you have two choices, either not to buy it or to adapt everything you do to that platform, off-the-shelf platform, opinionated platform that you took. And almost all cases that I know of, sooner or later, bigger companies abandon vendor opinionated platforms simply because it's impossible to adapt everything we do to the platform. We need to build platforms that will do what needs to be done according to our needs, right? And for that reason, most of the companies now are building their own platforms, and that is especially true for bigger companies. And then the question is whether you're building it from scratch or not. I believe that we should never build from scratch. When I say from scratch, open Visual Studio Code, create a file, main.go, and start writing it from scratch, right? We have on the market tools that enable us to do that. We have the tools that enable us to create a platform that is doing exactly what we want, that is specific to the company where we work in, and still do that relatively fast. So whether you build it or you buy it, certain rules must be followed. It must always store changes to Git. So that means that you cannot use tools like Rancher, for example. That's just silly, right? It must store the state in Git, the desired state. It is the source of the desired state. It must have a universal API. You cannot go through 75 different APIs, and it must have a control plane. Those are the rules of the game today, right? I didn't mention the universal control plane before, but basically what that means is that you have some kind of a system that will manage all that. Not you as a human, but the system itself, right? And that's what we call control planes. They're figuring out how to do everything that needs to be done, when to do it, and so on and so forth, right? And that's basically what you get if you take Kubernetes and then extend it to what you need. So if I would be building the platform today, which tools I would choose? I would probably choose Backstage for the user interface instead of building it from scratch. Crossplane for managing, extending Kubernetes custom resource definitions to do more than containers. Argo CD or Flux for synchronization between Git and the actual state, which we call GitOps today. Pipelines for one-shot operations, and everything else is whatever it is. Now, let me jump into the demo right away. But before I do that, let's see whether you have any questions. And then we can go into the fun part. I don't like talking too much before showing hands-on. So no questions. Okay, cool. Now let's go into my terminal, right? I'm a terminal guy. I don't like web UIs for many, quite a few different reasons. We can talk about it.
Hi, Victor.
Let me show you what I did before it. Yes?
There is a question in the tab of questions. So on the bottom to the left, you will see a red spot.
Okay. Bottom left.
Yeah. If not, I can. Yeah, wait here.
Yeah, put it on the screen.
Can you see it? Okay, I will read it. It's Guillermo.
Read it.
Yeah, who says, with Crossplane, what represents the stack you want to deploy? XR, XRT, composition, and what is the type of resources that you push to Git when, for example, a developer click on create my cluster with those parameters?
Yeah, can you remind me on that question in 10 minutes after I show the demo? Because I think that it will be answered in the demo.
Sure.
Okay, let's. Any more questions? This is fun. No?
It's the only one you didn't answer. Yeah.
Okay, cool. Sorry for that. I did not avoid the question. I just didn't see it. Okay, so what did I do before I started, came to this session? Well, I defined this file. And now imagine that I'm a developer. I'm not an operator, right? Or DevOps or SRE or whatever we call ourselves. But somebody else in my company created new custom resource definitions that I can use to make things easy. And I'm using here two of them. I'm saying, hey, I want to create something called composite cluster. And I'm saying here, it will be a cluster in AWS. I do not know how to do that myself, right? I do not know all the details. Do I need subnets, VPCs, internet gateway? I'm just saying, I want a cluster in AWS. I want the servers in that cluster to be medium. I do not know what medium is, not my problem. And I want to have 3 nodes in a cluster at least to begin with. Now, imagine this being a result of, let's say, an SRE maybe, speaking with me and everybody else in the company, asking me, what do you need? What are your needs? Oh, you need to create the cluster. Excellent. What do you want to control? And so on and so forth. I'm a customer. We came up, he understood my needs, and this is the result of it. So I defined this. This is something everybody can define. It's extremely easy, right? Kind of like we're talking about 10 lines of YAML. And I also defined this one called GitOps, which again is something that somebody else created for me as a service. I'm just consuming that now. And I'm saying, hey, I want to use Argo CD. Again, I do not know how it should be installed, what should be installed, how it should be configured and stuff like that. Not my thing. All I want to say here is that I want to use Argo CD. And this is the repository, my repository, that it should monitor, right? And by the way, the cluster where that something should be interacted with can be discovered through this secret, which will be created automatically by the previous one. So, and then what I did is that I did it in advance because it takes half an hour for AWS to create everything. I'm using AWS today. So just to save you from suffering to do it. But what I did with that file is that I pushed it to Git, right? I will not today interact directly with AWS or Kubernetes except in a read-only mode. So as a result of that, I already have Argo CD. Here it is. There we go. Let me log in. I pushed it to Git, and then Argo CD discovered that I pushed it to Git and made sure that this thing here, this single box here, is synchronized with my cluster, and that's the composite cluster. And this one called GitOps is synchronized here. And this is where Crossplane comes in. Crossplane converted those things which are currently defined as custom resource definitions. And going back to the previous question, the last one that I didn't answer, we call it composition or XRD and XR. XR are instances of that XRD. And Crossplane did whatever needs to be done, right? And there's a lot of things that should be done, but those things are irrelevant to me as a developer, right? And as an operator, I can also say get managed. So I can see the things from Argo CD UI, I can see it from dashboards, or if I like terminal, as I do, I can say, hey, Kubernetes, give me all the things that are managed by Crossplane right now. And you can see that a result of those 20 lines of YAML code are all those policy attachments, roles. Some things were installed in that cluster because it's not enough to have a cluster, but to have it production ready. And some other things are installed as Helm charts, and a node group was created, and a cluster, and a route table, and a security group, and so on and so forth, right? So this is now the differentiation between me consuming a service by defining something like this, and SREs in my company, or whatever the role is, actually making sure that this gets converted into what it really needs to happen, which are all the resources I showed before. Now, let's say, and the way how that was done, from operational perspective, I defined a new definition, said, hey, me as SRE, I want to provide a service to other people. I'm going to define Open API schema. It's going to be something like, I'm going to say you can define minimum number of nodes and node size and version. You're in charge of what this is, what the schema is. And then you say, hey, whenever somebody wants to use this service, that service should be converted into this. there should be some configurations and some objects created in that cluster and some more objects and so on and so forth. This is the full definition that somebody who really is familiar with AWS is going to define, but you as a consumer of that something. And this, by the way, is going to be exactly as my company needs it, not as some vendor thinks. And then you just consume it. Now, what is more interesting is, let's say that now I got the cluster as a developer. What I'm going to do is start using that cluster to run my applications in it. Let me execute this. This is not important. We can ignore it. What does matter is that now I can, in that new cluster, I got yet another Argo CD, right? Because I said I want GitOps, and I can prove it to you. This is the management Argo CD. And this one here is the CD, the Argo CD that was automatically installed in that cluster and configured to monitor a Git repository. And right now it has nothing, right? Here is nothing, and here is nothing. It is just waiting for me to say I want to run an application in a development or production environment. So let's do that. Let me define my application. Now, if you would want to define your application in Kubernetes, you would need to figure out deployments and stateful sets and ingresses, services, virtual services, a lot of things. But since SRS is my company, really nice to me, they created yet another what we called composition that says, hey, whenever you want to work with applications, you can just define something like this. You can say, hey, here's I want to create an application. That application should be backend application with the database. This is the image of my application, and that's about it. And by the way, I need a database for this application itself, not only application itself, not only code of my application, but application. And I want to define something called SQL. It should be Postgres running in my cluster. It should have some parameters like version. That's it. That's it. As easy as possible. And this application will later on connect to this database through the secret defined here. So how would I do that? And remember, I do not need to go to Kubernetes, to AWS, or anything like that. All I have to really do is to actually, what I'm going to do is that I'm going to copy the file to this directory, apps dev. That's the directory that Argo CD is monitoring. And I'm going to push it to Git. Git add, git commit, -m something, git push. And now, let's take a look at what Argo CD thinks about it, right? Nothing. And there is nothing here because it is synchronizing every 3 minutes by default. I can speed that up by saying refresh. Look at it. It created those two things. And Crossplane, in turn, created everything that needs to be created. And now I can go back to that cluster, and that's about it. My application should be up and running, right? I can access through the browser or the CLI or whatever I want. And if you don't believe me, here you go. Those are the two definitions that I defined, but nobody cares about those. And I'm going to move, they will be running soon, right? Application is already running, and database is about to be running. But let's move fast. Let's say that I want to now deploy the same thing to production. How would I do that? And the way how I'm going to do that is something like this. And now you can say, this is exactly the same as before. And the truth is, yes. I just changed here the host. And here I said, I want, in production, I do not want to run a database in my Kubernetes cluster. I want to run it as a service in AWS. RDS, for example, right? But again, all I have to do, because SRS in my company created compositions that will do all the magic. I, as a user, as a consumer, I can just say, hey, I want Postgres in AWS, not in Kubernetes this time. And then I copy the file to apps directory. I push this to Git, and then Argo CD. If I go to production, this was empty, right? Look at this. Does everything that needs to be done and still doing it. There we go. Look at that. And this looks the same, but it's not. It's defined in almost the same way, but now we're not running the database in Kubernetes, we're running the database in AWS. And I can prove that to you. How can I prove it to you? Let's say that I can go to my AWS console to show it to you. Let's do that. Login. Oh, I hate this. H5RH. There we go. And the password. Right. And if I go to RDS, here we go. Let's go. Right. Databases. There we go. Look at it. It's being created right now. It's creating here. I can do the same. I can show you the same information from Kubernetes itself, get managed. And then I'm wrong Kubernetes cluster. Wrong Kubernetes cluster. There we go. Come on. Go. But it's so slow. Thinking too much. This is embarrassing. In front of people behaving like that. Come on. There we go, right? You can see that it is creating RDS instance. It is creating DB subnet group and some objects in Kubernetes and some Helm charts and security groups and VPCs and internet gateways and route table and subnet for the database and so on and so forth. It is doing everything it needs to do. And yet, all I did as a developer was, define this, right? I'm consuming the service made by others. Easy for me, complex in the background, machines doing the work. And that's my 1 hour. I was too quick. Oh, I might have another slide. Let me see. Maybe I do, maybe I don't. I don't know. Do I have more slides? Yes, thank you very much. Any number of questions, I can stay longer here, are welcome. Check out Upbound, that's a company I work in. Check out Crossplane, that's one of the tools I showed you today. I have a podcast, I have a YouTube channel, and so on and so forth. And now let's go through questions. Let's see, what will you ask, if anything? Okay, so let me see. What is the last question I didn't answer? If I missed something, let me know. Masion, or I think I'm pronouncing it correctly. I don't know. What is the advantage over Terraform libraries, like what Gruntwork does? So there are quite a few advantages or important things missing in Terraform. And some of those things we had before Terraform, but we lost them. First of all, Terraform does not have an API, which is a horrible, horrible thing. It only works through a CLI. And I cannot really work with it in an API. I cannot create a UI on top of it. It's very hard. I cannot see the state of different things. I cannot combine different projects and so on and so forth. Second, Terraform does not have drift detection and reconciliation. It is running only when I tell it to do something. It is not constantly monitoring the desires, the actual state and comparing it with the desired state and making sure that everything is running. If my server goes down, Terraform will not figure it out. At least not Terraform alone. It could do it, but not alone, and it will not figure it out, and it will do nothing until the next time I execute it, right? Now, you can run it as some kind of a cron job periodically every 3 minutes, but even if you do that, it is still not showing you the relation, the states of all the resources, except when you're limited to a single project, which is a bad idea. And also, and all the other benefits, basically, that Kubernetes is giving you. Or to put it in other words, whatever the advantages we are thinking we are getting with Kubernetes for applications are the same advantages we should be applying to infrastructure. And the last thing I will say is that Kubernetes is part of a huge, massive ecosystem, primarily CNCF, Cloud Native Computing Foundation. That means that we have a huge amount of tooling and platforms and stuff like that that we can combine together. And whatever is running and is not running, designed to run in Kubernetes can combine all those things. So if I use Crossplane, let's say, and I'm using it as an example here, I can easily combine it with Promptail and Loki. I can easily combine it with Istio or Linkerd. I can easily do this and that simply because they're all part of the ecosystem. But Terraform is not part of any ecosystem in itself and doesn't have sufficient power to keep up simply because it's alone in a way. How does Crossplane, Jorge, then, how does Crossplane integrate with custom resource definitions? So Crossplane actually enables you to create custom resource definitions and controllers yourself. So it's not that much integrating with custom resource definitions, which you can through Kubernetes provider. Actually, you definitely can. But what it does is that it enables you to create custom resource definitions yourself by saying, hey, this is API schema, and I want it to do this, this, and that. And it will create a CRD, and it will create a controller. And that's actually how I created and managed the cluster, and GitOps and APP and SQL. Those four were all custom resource definitions. And I was creating custom resources based on those custom resource definitions, and Crossplane created the custom resource definition itself and the controller that is doing whatever it needs to be doing. And then says, Jorge continues, on the Argo CD graphical user interface, we can see quite a few resources that have been provisioned alongside your application, DB, clusters, VPC, etc., which are being displayed in a flat representation. The number can be a bit overwhelming. How do you handle complexity? Any thoughts on that? So, great question. So, depends from the graphical user interface. I'm going to show you how I handle it from terminal, and the same thing applies from graphical user interface, right? So, if I, as a developer, if I created this SQL, all I have to do is to say get SQL, right? I can do it same from a browser, doesn't matter. Different interfaces. Sorry, this is my cluster. Here we go. Come on. Oh, I don't know what I did wrong. Let me try again. Get, let's say, composite clusters, I think. There we go, right. So this is my cluster from the end user perspective. And there is, complexity is very low. It says everything I need to know about it is there. And that can be anything you design it to be. Hey, this is the name of the cluster. Sorry, this is the name of the resource, the name of the cluster. Control plane is active. Node pool is active. It is ready. And the number of fields can be anything you want, right? You can choose which information to expose yourself. And that's the same thing that I get from here, right? This is the level that you care about. I mean, that the end users care about. Now, some other people want to know the details, and then you go into all this, right? For the majority of people, Argo CD is just doing the stuff, and you can also collapse. I think that you can put it in a flat view here somewhere. I rarely use it myself, so I'm not sure how. There we go, right? A-team AKS, here it is, right? You don't have to see all the dependent resources that were expanded from it. You can if you want to, depending on what is your expertise. Okay, what else? Which are, the number can be overwhelming, exactly. Jorge says we're using Pulumi as nest to create microservices abstractions, but handling infrastructure has become painful. Yeah, I mean, I'm not going to comment much on Pulumi, on Terraform and Ansible and CF Engine, and simply because it might sound like I'm now doing negative commercial for those tools, because Crossplane can be considered competing product. I don't think it's competing at all. I think it's a completely different category. But yeah, Pulumi, it's great. Masion says, it means that if you don't deploy on Kubernetes, let's say use AWS ECS or GCP App Engine, you will use a small dummy Kubernetes to use its control plane. That's precisely correct. I'm not sure whether it would be dummy, right? So I'm now talking about two different concepts here. One is using Kubernetes as a control plane to manage everything, right? And that everything can be applications running inside of that same Kubernetes cluster or a different cluster, or like in what you said, ECS or GCP App Engine or Lambda or Azure Container Apps or Datadog something. So there is Kubernetes as means platform to run your applications inside, right? And there is Kubernetes, which is what I'm focused on today, as a control plane to manage everything, no matter whether it's inside or outside itself. Does that answer your question, Masion? I'm not sure whether I'm pronouncing the name right, but I think we're over time, but I will continue answering your questions if they're coming until the organizers kick me out. I don't know how much time I have, so either
As
kick
you
me out
wish.
or ask me more questions.
That's no problem. If there is interesting questions, it's worth it to stay.
Yeah, I see Basion said, great, got it. Great, yeah. So the assumption really is that Kubernetes is so big now that it's commodity. Everybody has a Kubernetes cluster. Doesn't matter really whether you deploy your applications in Kubernetes or not. Anybody else? Remember, either you come up with more questions or I go. Leave.
Javier is asking if they can have a copy of the presentation and the script. Javi, the video will be recorded. You will receive a link with all the recorded video in 1 hour. Afterwards, we will publish it in YouTube, so you will have access to all of this. And Victor, if you want to share with me the slides, I can share with everyone. There is no problem on that.
Yes, I just pasted the link to the slides to the chat. I don't know whether that's the right place. If not, you let me know. Just one warning for the slides. I'm a geek, so my slides are special. They go in 4 directions: left, right, up, down. Up, down are details. Left, right are major sections. And these slides cover approximately 3 times more material than what I showed today. So it's more than what I showed.
That's perfect. And the questions that Guillaume asked before, I'm not sure if you answer it, the one that I read to you.
Which one? Sorry?
Yeah, let
Can you
me
read
copy.
it again?
Yeah, I will copy it on the chat because it's too technical and I'm afraid I will not pronounce it well.
Okay. I think that I answered through some other questions and also through the demo what you ask about crossplane represent the stack you want to deploy XRs, XRDs, compositions. I think I answered it. If not, let me know and I'll give it another try. And then there is Guillaume. So what is pushed? On Git statically by the IDP management team, and what is pushed on actions by developers? Nah, I don't care. So IDP is just an interface, among other things. I mean, there are many other things, but you can push directly to Git, or you can go through some web UI that will push it to Git. The important part is that it doesn't matter how it gets to Git, it needs to get to Git. And the only way to change the actual state, to change your clusters and servers and applications and stuff, is by not touching them, but by going to Git, through Git. So who pushes it, how, doesn't matter. Whatever works for you. Jorge says, did not want you to comment on other infrastructure code tools, but how do you make sure to replicate and automate crossplane instances? Would it require having some Terraform or Pulumi script to provision your cluster? Okay, so, and correct me, Jorge, if I misunderstood your question, right? I think it's a question about chicken and egg. So you need to have a Kubernetes cluster, one cluster, to run crossplane. So you cannot use crossplane to create the first cluster. And so you need to create it some other way, either by clicking a button or by using EKS Cattle or Rancher or whatever. Once you have a cluster and once you install Crossplane inside that cluster, then you can tell Crossplane two things. First, from now on, you can create all other clusters and manage them. But also, from now on, you can manage yourself. So you create cluster any way you want, and then once you install Crossplane, you can tell now you manage yourself in the same way as how you would manage all other clusters. One thing I was doing, for example, I would often start by creating a cluster creating a local cluster like Rancher Desktop or Docker Desktop or Minikube or anything, install Crossplane, and define my first real cluster. And then Crossplane creates it. And then I move Crossplane over there and say, now I don't need local cluster anymore. You manage yourself and everything else. I hope that answers your question, Jorge. If it doesn't, let me know. I have then, thank you. And Alexis says, what happens if the Kubernetes cluster, which manage all other resources, goes down? Almost nothing. And that's the beauty of having everything in Git, right? If I have always the desired state in Git, if something, first of all, it's very hard for Kubernetes cluster to go down. That's very, very hard to accomplish, but it's possible because, you have 3 control plane nodes that are in HA across different zones, unless you're running on-prem, and then it's difficult. Anyways, but if it does go down, create a new cluster, apply those manifests from Git, and you will get the same result because all the desired state is stored in Git. You can reproduce everything. The only thing you cannot reproduce is the data, right? Like data generated in databases and stuff like that. But ignoring data now, and assuming that you have backups and stuff like that, you can reproduce anything, anytime, because everything is always stored in Git. The exception are few resources in AWS, and AWS is special. That this problem does not exist with other providers. AWS has few resources that cannot be named, with names that are auto-generated, like VPCs and few others. And for those, you need one tiny additional workaround step, defining external name, which is easy. Masion, do operators might use Terraform under the hood to handle creation, update, or drift? I mean, they could. They could, yeah. I would argue that Kubernetes is the best platform to do those things, but yeah, it could be Terraform as well. Alexis, does Crossplane delete all resources deployed in AWS, Azure, and etc., etc.? Yes, it deletes everything. When I finish this session, I will delete everything from my Git repositories that I push there, and then Argo CD will synchronize that with my Kubernetes cluster, and Crossplane then in turn will delete it. I can also choose to prevent Crossplane from deleting things if I want to, but in this case I didn't. So Crossplane will delete everything. So Crossplane will do whatever, whichever resources are defined in Kubernetes. And if I delete those resources, then the real resources like cluster and what's not are deleted as well. Now I'm not sure I understand, Alexis, what you mean when you say, if the cluster goes down. So, okay. So, you mean, correct me if I'm wrong. Maybe, I think I got it, Alexis. You mean if a cluster that is managed by Crossplane goes down, then yes, Crossplane will recreate it. If one server goes down, if the number of nodes changes, it will correct. It will always try. You cannot be 100% sure, but the goal is Crossplane is continuously monitoring everything. So whenever something changes, whether that's a failure of the whole cluster or a single server or changing some configuration, whatever happens, Crossplane will detect it through Kubernetes as a drift, and it will reconcile it. It will do whatever needs to be done. Sometimes that's delete something, sometimes that's update, sometimes it's creating something. I hope that answers your question, that I understood it now, Alexis. Any other questions? By the way, while waiting for questions, here's my YouTube channel. If you ever want to see, basically what I'm telling you now are the things that I'm regularly publishing over there. Anybody else?
Last question. Let's see if we have any pop-up. Yeah, there it is. Someone is typing.
Oh, this is nice. I see who's typing. I see the two people are typing. Oh, Guillaume, thank you. Thank you. And Alexis, thanks. Yeah, thank you, boys and girls. Thank you, everybody. I think that we have no more questions. Thank you so much for coming. I really enjoyed it. And also, you will find me on Twitter, LinkedIn, whatever. Any questions, anything I can help, ping me, and I will help out.
Yes, actually, we will share also in the mail like your link to your social media. So if you want to follow Victor, it's going to be easier. I will share again where we're going out of the session. The link if you want to log in on Math, I shared. That's my mail. Please contact me. I will be happy to talk with you, to know more about freelancing, to help you to boost your career. Even if you are only thinking to becoming, or if you are a freelance and you want specific projects, we are here to help you. So don't hesitate to send us a mail. We are more than happy. And Victor, thanks for coming. It was super interesting. I'm not the expert. I could not follow all the stuff you said, but some of them I'm starting to understand it. I think everyone is thanking you the session. It was a great questions. So we are more than welcome you if you want to do more Malta Academies. We will be more than happy.
Brilliant.
Thanks, and see you in other Malta Academies, guys.
Cheers.
Bye.